Okay. Later. I don't know. I haven't known. Trig identity practice. You can tell me. Here we go. Number 1. Okay. For all of these, our directions are going to be verify the trig identity. Okay. Verify the trig identity. And if that's too noisy for anyone, we can close the door. Anyone? Do we need to close the door because of the wood shop? Yeah. Yes? All right, here we go. First one. Okay, there's our first one. Sine theta plus cosine theta, cotangent theta equals cosecant theta. All right. And so what we want to do is take that left-hand side of the equation. Typically, it's the left-hand side. You want to manipulate the left-hand side and make it look like the right-hand side. What you cannot do here, okay, we cannot add the same thing to both sides here. We can't subtract the same thing, multiply the same thing, divide the same thing to both sides. All right, because when you do that, that's assuming that the things are already equal. Okay, but if we're trying to prove things are equal and we prove it by assuming they are equal, well then you kind of, you're not really proving anything. You're already using that fact. Okay, so what you have to do is kind of stick with one side and manipulate it to look like that right-hand side. Okay, now, some things that I just want to point out to you that may give us clues about what to do. For example, I see addition here, right? There is no addition over here. So somehow we need to try and combine these together. Okay, somehow we maybe combine these together. Perhaps we can get like terms, for example. Right now, these are clearly not like, right? They would not add together, but perhaps we can manipulate things in such a way that they would be like terms. Okay, that's one option. And that's pretty much all I can see right now. So I see 2 terms, right? And we want to get it down to 1 term here. Okay. So, and looking to try and work with this, right? We want to try and get this down to 1 term. Maybe simplifying might be kind of like a good strategy here. So what kind of how can we maybe, rewrite this somewhat to help kind of make some first steps here? So Ramike, what's your thought? Sine over cosine. So in fact, I'm going to go ahead and just change cotangent to be cosine over sine. We'll just do that first, right? I'm not going to bother rewriting that right-hand side over and over again. Okay. All right, so far, this is not what we normally experience, right? Because normally when we rewrite the cotangent, normally this will cancel, but those don't cancel, right? Cosine and sine, they don't cancel. But let's just kind of keep going with this. So if I wanted to multiply this together, what would I rewrite this as? This product right here, what can I rewrite that as? Cosine squared over sine theta, right? Okay. Can we add these 2 things together? Sine theta and cosine squared theta? No, they're not like terms, right? And in fact, we made something that wasn't a fraction. Now we've made it a fraction. So we might be a little whoa, are we even on the right path here? Because we've taken something that was maybe not a fraction, we've made it a fraction. That doesn't look, so great. But let's keep going here. If I wanted to add these 2 things together, what would I need to get? Common denominator, right? Okay. So what is our common denominator going to be here for these terms? Sine theta, right? Okay. This is sine theta over 1, and I need to be a sine theta there. So we'll multiply this fraction by what to get a common denominator? Yeah, well, just sine theta over sine theta. Okay, just like that. We're going to multiply by 1. Okay, multiply by 1. And if we do that, we get then sine squared theta over sine of theta plus cosine squared of theta over sine of theta. Okay. Do we have like terms now? Yes, we do, right? We can combine those, okay, to a single fraction. And that single fraction will be sine squared theta plus cosine squared theta all over sine of theta, right? And with this information, what can we say from here? Yes, Megan.
You can say the numerator is equal to 1.
The numerator is 1 because of our Pythagorean identities, right? Okay, exactly right. Sine squared plus cosine squared. We see it show up in there. So we get a 1 there. And what is 1 over the sine of theta? Cosecant of theta. So there's our answer. Check. It works. Okay. So since this is equal, that means those are equal, those are equal, those are equal, those are equal, and those are equal. Okay? Yes, right.
Why is that equal 1?
Why is that equal 1?
Yeah.
Well, so you were not here Friday.
Not once.
You were here Friday, okay. Well,
Don't even understand.
all right, real quick then, let me just show you here. Theta, A, B, and C. So we have a right triangle. We'll label the lengths A and B, hypotenuse is C. Right? The sides are in this relationship.
Is it one of the identities?
Yeah, exactly right. It's a Pythagorean identity. Yes, Pythagorean identity. This is 1. So wherever you see this, you can replace it with a 1. Replace it in its entirety with a 1.
Is
So
it the main one?
it's the main one, yeah. Okay, that's exactly it. Yes. Okay. For those of you that weren't here on Friday, we learned about Pythagorean identities. This is one of them. When you see sine squared plus cosine squared, okay, sine squared of theta plus cosine squared of that same theta, that is equivalent to 1. Okay? And it comes from combining Pythagorean theorem with our sine of theta and cosine of theta, and like this being theta right there. Okay. And I can go over that some more if you'd like to, or you can check it out in the video too. Either way. Okay? Questions on any of that? All right. And that's not the only way to go there. That's not the only way to go. For example, maybe if someone saw cosine squared here, they might have said, oh, okay, well that's then, we know that cosine squared is the same thing as 1 minus the sine squared of theta over sine of theta, bless you. Okay? And then this is kind of crazy right here. We can break up that numerator. Right, so the 1 minus sine squared, which we changed from cosine squared, 1 minus sine squared, we can break it up and say 1 over sine theta minus sine squared over sine theta. What's 1 over sine of theta? Cosecant. What's sine squared divided by a sine? Just sine. Sine minus sine, those will cancel, and again, you're left with the cosecant of theta. So that's another way to do it there, too. Okay, so there's more than one way to get at your verification there, possibly. You don't have to do it all in the same way. Okay? Questions on that one? Okay, let's try another one here then. All right, let's say secant x minus tangent x times cosecant x plus 1. And we'll say that's equal to the cotangent of x. Okay. So secant x minus tangent x times cosecant x plus 1 is equal to cotangent x. All right. So, thoughts here. What might be a good thing to do first? Ideas. Well, again, you can see we've got two things we have to multiply together. Here, we have, two things multiplied together, and then here we just have a single term cotangent. So, yeah, Megan, what do you think?
Change secant x into 1 over cosine x and tangent x into sine x over cosine
Okay, and then cosecant, I'm guessing also. So let's change everything to be in terms of sine and cosine. And that's a good general strategy to try and follow here because every trig function can be rewritten in terms of sine or cosine, and that'll help us with cancellation and stuff like that. So secant, yeah, let's make that 1 over cosine. Tangent is sine x over cosine x. Cosecant x is 1 over the sine of x, and then plus the 1 there. Okay, like so. Question?
Well, I was going to just say, like, can't you just turn the secant minus tan back? Can't you just turn that into 1? It's not one of the equations.
Okay, be careful. Pythagorean identities require you have secant squared and tangent squared. We just have the regular old tangent secant. But good thinking there. But yeah, we need the square. Okay. All right, so now everything's in terms of sine and cosine. How can we maybe go from here? So, yeah, Ramike, what do you say?
Subtract the equations from the parentheses and like add the.
So we have like terms, so put them together as a single fraction. So we have like 1 minus sine x over cosine x there. And then how about this one? How can we rewrite this one? Yeah, so yeah, this 1, we can rewrite that as sine x over sine x. So we'll have 1 plus then. 1 plus sine x over sine x. Bless you. Like that. Okay. So far, so good there. And now what might be a good idea to do? Multiply. Yeah, let's try multiplying here. So when we multiply fractions, we multiply across the top, multiply across the bottom. The bottom's going to be easy. It'll just be cosine x sine x. Right? Nothing too crazy there. The top, though, to multiply these together, we're going to have to like FOIL, right? Because you have like a binomial and a binomial there. So it'll be 1, it'll be minus sine x squared, minus sine x and then plus sine x. So that's going to be gone. I'll go ahead and write it out there. And then minus sine squared x, like so. All right. And then we can simplify, right? Those middle terms cancel, and we have 1 minus the sine squared of x all over cosine x sine x. Okay, we've got a single term here, but that's still pretty messy as compared to cotangent of x. But what can we still do further here?
You can turn the numerator into cosine squared x.
Right, yeah, so 1 minus sine squared. Remember that we have the Pythagorean identity, sine squared x plus cosine squared x equals 1. Right? That's from what we learned on Friday. If we wanted 1 minus sine squared, I could subtract the sine squared from both sides. Mr. Whitmire, you said we're not allowed to do the same thing to both sides. This identity we've already established is true. This identity we have not established to be true. That's what we're trying to do. And so that's why we have to work only from one side on this one. But here, since it's true, we know it to be true, we can subtract sine squared from both sides. And so this is cosine squared. And now what can we do? Now that it's cosine squared, what can we do? Cancel out a cosine, right? And we've got cosine in the numerator and a sine in the denominator, which is equal to cotangent x. Check. Check, 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 check. Okay. That's pretty neat. Okay. Did anyone have a different thought about how to do this one? Everyone thought that was okay? Or everyone think of it, trying to do it a different way here? We all think the same? Good. Good. Just kidding. There are other ways to do this, for sure. For example, you could have started out by foiling right here. It'd be kind of messy, but you could do it. It does work. Okay? You could foil right here if you wanted to, and then turn everything into terms of sine and cosine. That'd be fine as well. Okay? All right. One more. One more here, and then we'll have you guys try some on your own. Because really, I can show these to you, but you're going to have to really wrestle with these on your own. That's really what this is, or, together, I should say. But you'll have to really, that's how you kind of develop a sense for these. Okay? So do one more here together. And this one's going to be fun with fractions. start with 1 over the sum of tangent x and cotangent x. And we're going to say that is going to equal sine of x times the cosine of x. Believe it or not. So, thoughts here. What should we do? So, okay, Ramike. Okay. Let me just pause you right there. So, like this, yes? Oops, I'm not going to keep writing that. Okay. So yeah, and so then you want to say that's tangent x over 1 plus 1 over tangent x, right? Like that, and you want to get then a common denominator. So what's our common denominator going to be here in the denominator? Tangent x. So we'll multiply the first fraction here by tangent x over a tangent x. Okay, so we get then 1 over tangent squared x over the tangent x plus 1 over the tangent x, like so. Okay. And since they have common denominators, we can just make it then 1 over tangent squared x plus 1 over the tangent of x. Right? Just like that. And then how can we rewrite this? We have 1 over that thing. What does it become now? Yeah, instead of dividing by a fraction, we're dividing by the fraction tan squared x plus 1 over tan x. Let's multiply by 1 by the reciprocal, so it's going to end up really just being this. Tan x over tan squared x plus 1. Like so. Well, that's not too bad. Can we break up the numerator? Sorry, can we break up the denominator, make this tangent x over tangent squared x plus tangent x over 1? Can we break that up? No, okay. Remember, we can't break... What's that? Yeah, it's a frowny face, right? Yeah. No, you can't break up your denominator. You can break up your numerator, but you can't break up your denominator, okay? So we have to leave it like that, unfortunately. But what's tangent squared of x plus 1 the same as? Secant squared x. Okay, again, that's another Pythagorean identity for those of you that weren't here on Friday. Okay. We're awfully close. Awfully close. What might be a good next step here? You'll notice here we're shooting for something with sine and cosine. So what should we maybe do now? Make tangent, yeah, what? Sine x over cosine x, exactly right. Secant squared is 1 over cosine squared x. Okay, so instead of dividing by 1 over cosine squared, we'll multiply by cosine squared over 1. And oh my gosh, the cosines cancel. And we have sine x, cosine x. Check. It's true, it's true. Okay, so they are, in fact, equivalent. Okay, I will not be giving you, like if I'm asking you to verify here, an option will not be that they are not equal. Okay, if we're asking you to verify that they are equal, we're telling you that they are, in fact, equal. Show that it is so. Okay, show that it is so. Yes.
Well,
the quiz will be timed. The time limit will be the class period. You know, normal kind of class.
I didn't know if you were going to
Nah, I won't do like 10 minutes, go. I won't do anything like that. Yeah, but within the limits of the class, of course. So yes, you'll be graded as partners. So what one person in your group gets, everyone in that group gets. Okay, unless I find that one person is doing absolutely nothing and the other people are completely doing all the work, then there might be some manipulation.
And will it be one quiz between everybody?
It'll be. I'll get you 3 sheets of paper, but I'd like you to all combine your answers together. Some students elect to kind of like delegate different questions to different people. Some, and then, so it depends. But I'd like you to try and get them all on one sheet of paper because it's easier to grade that way. I'm not like looking for everything, kind of thing. But ideally, we get all on one sheet of paper. Okay. So, other questions for me on anything? That's it. That's all I wanted to show you right there. Okay. So those 3, and then you're going to work on them on your own now. Yeah. Yes. So on the Google Classroom, on our Google Classroom, there are some practice verifying trig problems on a worksheet, okay? And that's what I want you to work through there, okay? You already know they're equal. It's a matter of manipulating it and convincing that they are, in fact, equal, okay? So let's do it to it here, folks. It'll be homework if you don't finish, yep.
Oh, you're done early.
Yes, out of spite.